Hi, everybody. I'm Catherine, and I'm an account executive and partnerships lead in the business development part of Codee. So more related to business and helping people evaluate Codee in their software development process. And now I will let my team introduce themselves.
Hi, I'm Tamara. Nice to meet you. And basically, I'm part of the technical team of Codee and will be guiding you today through the live demo and showing how the tool works and giving a little bit of context of the insights of the tool. So it's a pleasure.
Okay. Thank you, Tamara. I'm Ulises Costi. I'm from the Codee engineering team. I work on quality assurance, technical support, and I'm here to gather feedback from you and be in support for anything it is needed.
And finally, on my side, my name is Manuel Arnaz. I am co-founder of Codee, which is the commercial brand for our product. The company is called Apento Solutions. Maybe you heard of it in the last supercomputers for the past 5-6 years. And essentially, we are headquartered in Spain, and all the team dedicated to the development of Codee is mostly located in Europe. And my role here is essentially to help with any questions or any comments you might have after the presentation done by Catherine and Tamara, and also try to understand kind of with a product owner hat, try to understand what Codee is doing today that is satisfying the needs for Fortran development software processes that you might have an UCAR or UCAR, and also identify any other features that in the future might be useful or very relevant for you, so that we can influence our software development roadmap for the product. It's kind of this is my role here today. So thank you very, very much to all of you for attending today. And thank you, Brian, for facilitating this.
Thank you. So now I will share my screen. And then if somebody can confirm that they can see it properly.
Yeah, we can see it.
Perfect. Okay, so I'm going to go ahead and get started. Thank you, Dan. So a quick intro to Codee. Codee is a code review and testing platform that focuses on Fortran, C, and C++ that ensures that code is correct, secure, modernized, portable, and optimized. And currently, we work globally with many organizations like UCAR. For instance, we work with Oak Ridge National Laboratory, KAUST, DKRZ in meteorology, in Germany specific, and a couple of other companies in the aerospace, defense, nuclear energy sector. And what they all have in common is that they are supporting widely used Fortran base codes, such as CP2K, Open Radios, WRF, Icon, Siesta, FASTA, HICOM, MPAS, and all these codes are still being continuously maintained and developed. Today's agenda is I will do a quick introduction to Codee. I don't think that will take me more than 8 minutes. And then I will hand it off to Manuel and Tamara, who will explain more about Codee's products, the Codee formatter and the Codee analyzer and their respective demos. And then we'll leave a couple of minutes at the end so that if there's any questions, please feel free to put them in the chat if that's easier. I don't know if you usually use the Q&A section of the Google Meet. Brian, I'll let you decide in that sense. For us, the chat is also completely fine if people want to go writing their questions as they come up to their heads. Okay.
Yeah, I think using the chat works well.
Okay, perfect. Okay, so to get started, from our conversations with the Fortran community, we've learned that while Fortran remains essential, ensuring that the code is fast, maintainable, secure, and correct is a very common challenge. And there's a couple of best practices that help this issue in maintaining codes on the long term. Some of these are, for example, a use case is formatting. So we know that there's a lack of tooling currently in the Fortran world, and more specific with formatting. So in that case, we have a product that helps with that, Codee formatter for Fortran, which is free, and we'll do a demo later on that. Another use case is to catch bugs earlier and prevent them in the future proactively. In this can happen through the static analysis that Codee does. Another one is address security vulnerability. So as critical Fortran infrastructure becomes more and more internet connected, it is a prime target for cyber attacks under new regulations like the NIST in the US and the EU's Cyber Resilience Act. So Codee provides both static application security testing and software composition analysis to help find security flaws in your code and manage vulnerabilities in your dependencies. Another use case is enforcing project-specific coding guidelines. Some organizations have the coding guidelines, but there's not an automatic way of implementing them or a tool that helps with this. So Codee is one of those. Modernizing legacy code. We know that there's a lot of legacy code out there, still a lot of codes with Fortran 77 that needs to be updated to newer standards. And this also ultimately prevents bugs and improve maintainability. Ensuring portability across compilers and architecture. So for instance, we've seen a lot of clients having the need to migrate from the Intel Classic to the Intel One API compiler, for example, replacing the in-house ad hoc Fortran analyzers that at the end of the day, a lot of times this is not the main role of the development group. It's something that they had to create to accommodate for the fact that there's not a lot of tools in the industry. This is not their main objective. So that also takes away resources. And then lastly, a tool that is able to be automated in a CI/CD framework. This also helps maintain the code quality over time. So all of these use cases, Codee can help with all of this. And after you ensure that the code is correct, secure, modern, and portable as a second step, we always recommend then you can consider optimization if that is one of your priorities. So more specific, what are Codee's capabilities and how does it help in a programming environment? So currently Codee supports from Fortran 77 to Fortran 2023, fixed and freeform, standard language, and compilers on standard dialects. And essentially Codee is intended to enhance your current program environment. So I imagine you guys use compilers, libraries, parallel programming, etc. And Codee brings a new set of tools to the table that are 100% compatible with CI/CD pipelines, given static analysis, formatting capabilities. It is self-hosted, so none of your code is going to a cloud or to us, with security features and reports like static application security testing, software composition analysis, and then there's also options of auto fixes. So Codee will give you a command, you copy and paste it, and it will rewrite the code for you. And Manuel and Tamara will explain a little bit more about that. Now, before I hand it off to my team, how do we intend for Codee to be used in a developer's workflow? So without Codee, the developer usually modifies the code, compiles it, and then runs and tests it. What we intend with Codee is that after you modify the code, you add a step using the Codee formatter and analyzer, then you compile the code, and then you run and test it. Okay, so now we are all waiting for the live demo. So I'm going to stop sharing my screen. And I will let Tamara and Manuel share theirs.
As I will, let me know if you can see this, because I will jump into the terminal, so it's easier for me to just share the complete screen. Is everything okay?
Yeah, I can see it.
Okay, so again, let's talk about the importance of having a consistent style in a code base. So as you probably know, simply reading across a code and trying to understand how it works and how are the functionalities implemented is already a difficult cognitive task. So whatever we can do to ease this process is more than welcome. For that, we believe that having a consistent style and that all the members of a team developing a tool have the same style is very important in order to maintain the code and to keep adding new features. So for that, we've developed a Codee format, a tool that can automatically format your code according to your needs. There are more than 50 style options, and it works both on fixed form and free form. So if you agree, I will jump now into my terminal. Please confirm if you can still see everything properly.
Yeah.
Or if you need me to make it bigger.
Yeah, I would make it a little bit bigger.
Okay. Oops. Let me check here. Well, I'm not being able right now to make it.
In preferences, and there you
Yeah,
have the font size.
Yeah, I think that's good.
Yeah. Okay.
Thank you.
So to get started very quickly with the demos, we will be using our public repository of Codee demos. So I will just clone it. So if you want to follow our quick start guides and reproduce this example, you can do it in the exact same way that is in our website. So I will move to the Jimeno project. That is a project with a single Fortran file. And first of all, before doing any changes to the code, I would like to show you the config file that allows you to configure Codee format according to your needs. So typing this command will generate this default configuration for Codee format. And here you can see all the different parameters that can be adjusted, so you can adapt the tool to your coding guidelines. So very quickly, Codee format, if you type it like this, it will perform the formatting according to the default configuration to all the Fortran files that find in that directory and the directory below. But you can also focus on a single file. And for the sake of this demonstration, so you can see what it's been doing the tool behind the scenes, I will type the verbose flag. And if we run it, we can see that over 500 changes were made to the code. So now if we simply do a diff of the Jimeno file, here you can see some example, like for some spaces were added. The keyword kind was also added for the real, and just as an example, so you can see how quickly it works. And of course, we won't be showing you in this live demo how it can be integratable with other tools, for example, your IDE or your CI/CD pipelines. But if you're interested, we can share with you the online documentation so you can review these topics too. So you can see how easy it is to integrate Codee format in your current workflow. So that's it for the part of Codee format. And now let's jump into the Codee Analyzer part. Well, just as a reminder, Codee Analyzer is the component of Codee that helps you to improve aspects of your code related to correctness, modernization, security, portability, and also optimization if that is something of your needs. And it achieves this by following the recommendation that we have in the Open Catalog. This is an open source project that you can contribute or make questions through GitHub. And here we have all the recommendations that we consider to be important for a high quality and optimized Fortran code. And here, for example, if we enter in one of the entries, we can see an explanation of the issue, the relevance on why it's important to address this type of issues, and also examples on different languages like C and Fortran, and the before and after. So that being said, I would also like to share with you some success stories that we have with open source software, just so you can see how many checkers were found on these code bases and how many time it took to analyze the full code base. To continue just straight to the point, here you can see a basic query execution, and I know that probably seeing more than 80 checkers, as we've seen in the open catalog, can be a little bit overwhelming. So it's usual that when you do a Codee checks report, to filter by the check ID, you can add as many checks ID and decide with your team which ones do you want to address first. So here we filter out only the recommendation 7, which is related with the implicit declaration of variables. And here you can see the Codee output, how it shows a little explanation on what is happening here, a link to the open catalog. So for the ones that are curious to try to understand why it's important. And also in this case, we have an autofix. What this does is that if I now copy and paste this command, the issue that is being reported by Codee will be automatically addressed. We are currently working on giving support with autofixes for all the checkers, but nowadays we have been giving support for those that are the, I would say, most common issues that are found in more repetitive actions that required from part of the developers. In this case, for example, the implicit none that is probably missing in that code snippet. And also, again, it can be overwhelming to have loads and loads and thousands of checkers printed in your terminal. So what we recommend as a first step is to perform a Codee screening report, and that what we will do is that it generates a ranking on how many occurrences, and it will order by priority and by checker the ones that are listed as highly recommended to address before. And then you can, with your team, with internal discussions, decide which ones do you think is better to address first. And let's now jump into the live demo. First, just so you can understand what is the common workflow and so you can see how the tool actually works, we will follow the quick start guides that is available in our website. And then we will perform a screening over MPAS while we answer any question that you may have. So you can visit our website and have all the steps, the step-by-step guide. So everything is nice and clear and we can see the tool working fast and without any troubles. So I will I will stage the changes. So because we are going to make some changes to the files. So when we do the changes and the git diff, we only see the actual output of the new changes. So here you can see the quick start guide. First of all, we need to make sure that our code is compilable. I know that in this case it is, but as a good practice, I will share with you the compiler invocation. And now we can see that the compiled object is created, so everything is working fine. Okay, so the way Codee works, for example, this first checks report, we should launch Codee checks, and in this case, we will pass, so Codee knows what is the compilation command that is needed for this project. In this case, the same as before, and I run it, and now you can see a list of all the checkers that were found in this code base. In this case, we have 26 checkers, but with this mode, we only see the title of the checker. So what most of the users do is now select one of the checkers that they want to address. For example, let's pick recommendation 69. If we want to review more than one, we can always type a list of separated checks ID with 15 or 10, whatever we want. But in this case, we will only work with this recommendation 69. We run it, and here now we can see an explanation, for example, for this checker on what is the issue. If we want more details, it also includes a link to the open catalog, same as before. And finally, we can see here that an autofix for this issue is available. So now, if I type this command, we can see that it was successfully updated. And now, if I do a git it over the modified file, I can see that it automatically applied the use only to the variables that needed it. So for the checks report, that's basically the workflow we recommend. And you now might be wondering what happens. Okay, in this project, I only have one file, but what happens if I have thousands of files? Do I need to every time write the compilation command for each file? That could take a long time. So as you can see in our documentation, we rely on a JSON file named compile command station. There are several ways to obtain it, but packed with Codee, we provide the Bear tool that is open source and that we actively develop to give more support to different compilers, to different wrapper of compilers. So in Linux is the best option because it's useful with many build systems. So in this case, I will try to compile again. The usage is very simple. Simply type bear -- and the compilation command that you usually use. In this case, we have a make file, so we type make, but imagine you have a script. You can also type the compilation script or whatever. So this, what we will do, will parse the compilation commands, and now we will have here the database that will that Codee will consume to produce the output. So as we mentioned before, that there was a screening report. If now I tell the tool to perform a screening and tell where to, with the -p flag, I can tell them where to search for this database. So now if I run it, I can see two tables. One is the ranking of quality checkers, and the other one is the one for optimization checkers. And basically, that's the main functionality. Now, what is probably more interesting for you is to see how this behaves in the MPAS code that probably most of you are familiar with. So let me clone the repository of MPAS. And now, well, I compile it this way. First, I perform the configuration step. And finally, again, now that it is a makefile available, I type there dash, and the compilation command needed to build my project. In this case, in my computer, it will take a huge amount of time. And so for the sake of simplicity, I have here open this other terminal with the compilation already done and the compile commands already generated, the same way that you see them here. So I will simply produce the screening. And if you all agree, while this runs in a second place, we can start answering any questions that you have.
Just to point out, Tamara, maybe in a terminal you can show the content of these JSON files for Imeno or for any of them, so that the team can see the actual invocation of how the code is actually built in its release version or its debug version of the code, just to see how it looks like internally.
Yeah, just for simplicity, I will show the Imeno one, if that's okay. For MPAS, it will be the same, but with loads and loads of entries. And here you can see the arguments used to compile and also the paths where Codee can find the source code. And that's basically how the JSON file is structured.
So in practice, if the team of MPAS, for instance, to take this example, you're building releases of your software with different compilers or different compiler versions of different systems, to have Codee reports that provide you the screening or the checks report for the different releases is just maintain or generate different JSON files with the different compiler options you actually used, and point Codee to the different JSON files so that you can get independent reports that affect to the subset of files and the subset of flags that you use in practice for the release of your software to your customers or users. Okay. So any questions? Yes, Brian?
Yeah, I mean, this is kind of a high-level question, but I was thinking about it during the initial presentation. So, you know, it's nice to see tooling that's targeted, at least partially towards Fortran, since there's not a ton of that anymore. But I didn't see any mention of like Fortran GPU coding. I'm wondering if that's something that you all support or are thinking about supporting, things like OpenACC code in Fortran and also language standard parallelism.
That's a good question. We have been developed features in that space with our colleagues of the DOE, of the Organizational Lab, the OLCF team. And essentially what we developed is auto-fix capabilities for Codee to detect loops that can be offloaded to a GPU or executed in multi-threaded mode or executed in vector mode. And Codee auto-fix adds or decorates the code with valid OpenMP or OpenACC directives, as well as compiler directives like Intel compiler directives or GNU compiler directives. We also have documentation in the website. Let me share my screen quickly. In the online documentation that Tamara mentioned, docs.codee.com, we also have a platform section where you can see essentially, for instance, for an HP Cray EX, which is a machine that has been used historically or typically in OLCF. You can see, for instance, in benchmarking sections, how to take ucar, one of the examples of codes of interest for OLCF, how you can, for this level of complexity of code. Simply with the same commands, Codee checks and the JSON file, just ask Codee to focus on checkers related to CPU or GPU offloading. Then you get the same check report. And in the verbose mode, this is the interesting thing. It's as simple to use as you have seen with, in general, for quality checkers. But here what you get is a variety of auto fixes that allow you to insert OpenMP parallel for directives, OpenMP tasking directives, OpenMP offloading directives, different variations of how to code the parallelism using OpenMP directives. And after that, you can get the code, you can annotate the code. You can see here, Codee automatically infers the data scoping of each variable, if it must be privatized, shared, last private, first private, and so on and so forth. And finally, the execution, if the loop has enough workload to accelerate the execution, that's something that is out of control of the compiler, out of the control of a tool like Codee. This is simply the nature of the workload. Then you can get code that runs significantly faster. In this case, this UCAR kernel that OLCF provided us with for some developments is 20x faster. Okay. Sometimes you get a slowdown, sometimes you get a speed up. It depends on the loop itself, the amount of work actually done at runtime with the input data set. And if those conditions make parallelism, I would say, profitable, then Codee makes the job for helping you to annotate the code with the appropriate pragmas, or even find variable errors in the OpenMP or OpenSSE pragmas. For instance, if you go to checkers of optimization, we have what we call some defects. They should be maybe in correctness. Let me navigate here. Yes, correctness, for instance, we can see PWD 005. Just a simple example, how Codee can detect that a variable is improperly or not properly offloaded to a GPU in this case. In this case, it is that you need to specify the range, or just let the compiler infer the range of the data to be offloaded. So we have many capabilities in that direction. But as Kath tried to point out in the beginning, our experience is that, and this is where we began 5 years ago in optimization. We started to develop all those features. And we came to the conclusion with our colleagues at OLCF that many codes were not ready to start adding GPU offloading, for instance. Before that, you needed to prepare the code to be, let's say, ready in terms of data structures, how to pass the arguments to the subroutines, even having or not subroutine calls. Depending on many features of the code, you need to prepare it before using OpenMP or OpenSSE. And this is where we open a whole new world of features for Codee. That is the step number one: ensure correctness, security, modernization of portability. So this is why we say, always use Codee, try to get the license that unlocks all the capabilities, but please, for your own interest, start enforcing correctness, modernization, portability issues, fix them, at least for the kernels you want to accelerate. And only when you finish that, start consider adding some parallelism directives using Codee, for instance. So this comes from several years of interaction with these experts at OLCF. It's one of the communities we work with.
Thank you.
Sorry for the long explanation.
I see that there's more questions in the chat. Can you say more about what you mean by correctness checking? For example, is it checking correct syntax, or is it broader than that? Could the developer define correctness metrics?
Very good question. It is way broader than that. Correctness style checkers is what other tools can do, but we do semantic checkers. For instance, let me show you. I think it's interesting, for instance, very clear in the in-out, the intent of a variable, for instance. It may seem, example, yes. If you want to decorate a code or a subroutine with intent, you need, as a programmer, to analyze how each variable, each argument of the subroutine is actually used inside the subroutine code. And if there are calls to other subroutines, do it interprocedurally, across procedure calls. So, and in order to understand if it is read-only write-only or read-write, to simplify it. So Codee does all that data flow analysis for you. So it identifies the list of variables or arguments that have a missing intent or a intent that is wrong, infers the right intent for those arguments, and with the autofix allows you to fix it. Whenever it's missing, add it. Whenever it's incorrect, replace it with the correct one. So it goes, it's just an example, I think it's easy to understand, but it goes way beyond just syntactic checkers.
Great. The next question is from Dan. It says, let's say you wanted to format, and same question for analyze, a portion of code at a time that's organized by a folder. So basically you want to format, analyze all source files in that folder and all subfolders. Is that possible?
I think that we can go to the next question. And in the meantime, Tamara can prepare a pretty quick demonstration with any of the codes that we have with multiple files in our Codee demos repository. So let's go to the next one.
The next one is there VS Code integration for the formatter? Is there a way to disable certain checks for certain lines, blocks, procedures, modules?
The answer is yes. For VS Code and for many other IDEs or CI/CD platforms, if you go to docscodee.com, formatter, for instance, you have CI integrations with Git, GitHub, GitLab, even with examples of code that you can copy and paste and try to adapt it to your configuration. This is for control repositories and CI integrations, and the same for IDEs. We have it for VS Code with step-by-step instructions about how to do it, Vim, NeoVim, Emacs, all the main editors that our users report active usage of them. And the ability to disable checkers, yes, you can do it in different ways. You can do it in the command line just by selecting or deselecting a subset of checkers, or you can even in the code add some pragmas to say to Codee, analyze the whole code except, for instance, the section enclosed in this within these directives. What we do it with the formatter and with the analyzer in this regard is we try to mimic the great user experience that other tools provide for C++, like Clang Format and Clang ID. They provide all these suppression mechanisms, these ways of integrating the tools, Clang Format and Clang ID with IDEs and CI/CD pipelines. So we try to mimic the same level of usage for Fortran. Indeed, for those that come from those of you that are coming from C++ or have experience there, sometimes we refer to Codee as the Clang Format and Clang ID tools for Fortran. We are filling in these missing tools or this gap in lack tools that are not available, have not been available so far for Fortran software development, and that Codee is bringing to the community. Okay. But yes, in short, yes, we have a lot of documentation in the online documentation.
And then the last question here is from Helen. It says, can you expand on what security checks Codee provides versus compiler debugging flags? For example, out-of-bound checks on uninitialized variables.
Okay, that's a very good, indeed, a good question. Indeed, you can see in our open catalog, if you looked at the open catalog 6 months ago, so December last year, there would be no security filter here. But now you can see that many of the checkers we had already automated for correctness, modernization, portability, and optimization are now also under the umbrella of security. Where does this come from? We have analyzed the common weakness enumeration secure coding standard, which is for C and C++, and Fortran is, I would say, programming language agnostic. We have analyzed ISO ISC 247728, which is Fortran specific, and C because it's a widely adopted secure coding standard for C. And there are many checkers that actually apply directly to Fortran way of programming. So here you can see how many of the checkers of Codee actually align with finding potential security vulnerabilities in the code. So this is the first answer of the question. The second answer of the question, let me focus on one that has motivated some customers only this checker to buy Codee purchase Codee licenses. It is this undefined behavior one. Let me find it here. Yes, recommendation 79. So undefined behavior is something that can come from different ways of using the programming language. But for instance, a very clear example in C is using variables before initializing them properly, typically relying on the compiler to initialize by default. But this is not portable across compilers. And this is actually a huge problem in big code bases or legacy code bases being modernized. And the same stands for Fortran. The same problem with variables not properly initialized, leading to clearly incorrect results, none instead of the appropriate actual sum of the values of an array. And this is a very, very simple example that some compilers can detect, but others compilers fail to detect. And now the recommendation 79, we're also working on improving it to detect undefined behavior due to improper initialization of variables when there is complex control flows, if then else, loops, and all of them nested, which are very difficult and very tricky to identify by hand by a developer, and they cannot be automated by any compiler, and Codee can automate them. We are implementing this kind of features. I think this is a good example of how out-of-bounds checking or undefined behavior or uninitialized variables, the compilers, in short, can identify very simple situations where this happens, but more sophisticated ones, even simple for a human, they don't implement the functionality to detect them. This is where the static analyzer is a perfect complement to the compiler and enables the developer to do a better and faster development job. I hope this is a good example to reply and clarify this. Anyway, Catherine, you can also point our audience to the webinar about code security so that Brian can add it to the resources here so that you can see we have specific webinars in collaboration with experts in the industry. Codee.com resources webinars. And there is one in particular for security, other for coding guidelines with Brad Richardson, for instance, from NASA, very well-known Fortran community member. And here we try to provide webinars to explain what different problems are, security, how to enforce coding guidelines, how to modernize or format Fortran code, and to explain how Codee helps, what functionality Codee provides. Okay? Here in 30 minutes, I think it's explained very, very clearly what do we mean by security and where Codee as a tool can help. Maybe I can stop sharing and while we read other questions, maybe Tamara, if you're ready, you can do a demonstration of Codee format for a whole project.
You're muted.
I will share my screen now. And well, regarding to the questions that some leave in the comments, I already answered some of them. But basically, for example, do you see it now, right? For example, we have here the Labback example.
It is quite small. If you can make it bigger. Great.
Is it better now? Okay. So I think your question was, well, I already showed him how to disable with Pragma some checkers on specific points of a file. But imagine you only want to format or analyze. It works both ways. The files that are inside of the src directory. That way, it works the same for specific files. You can do Codee format and select the directory, or imagine also want to do the formatting on the testing. It also works. And if you, for any reason, would want only to format the, for example, these files, you can also do this. So in that way, you can format only this directory. And now it is, I don't know how many files, I think 4,000. So this might take up to 20 seconds or so. But if I open other terminal, we've seen in the live demo how to filter for specific checkers. In the case that we want Codee to report all the checkers except one specific one. For example, imagine that you don't want to know the occurrences of the recommendation 7 about the implicit declaration of variables. Then instead of doing check ID and the list of checkers, you can write no check ID and now the list of checkers. And that way, the analysis will be performed, but we will exclude from the output the checkers that we put here. And yeah, 40 seconds to format, well, that many changes in the code. So of course, if you want to format from 0 to everything, it takes a little bit longer. But yes, it's quite fast. And also, I don't remember who was asking about integration with VS Code, but I shared a link in the chat where you can see a specific integration of VS Code that every time you save, the changes are performed in the file you're currently working with. And you can, if you navigate through our website, you can also see integrations with other editors like Beam, NeoBeam, Emacs, or wherever the most common ones are covered. And if you ask us more, we will try to produce new documentation.
So in short, the command line interface of Codee Formatter and Codee Analyzer is sets of files, sets of directories, combination of them, even wildcards as you use typically in a Linux tool like ls with stars and things like that. So you can select or specify any combination of files using these capabilities. And you also can specify a subset of checkers you want to use or a subset of checkers you want to avoid using. So you have ways to filter both code and filter checkers of the catalog that are actually included in the report. Okay, the core interface is prepared for that.
Yeah, I also share a link to our frequently asked questions where these topics of filtering out files, directories are also covered. So you can also find that link on the chat.
Okay, so for the sake of time, Brian, what might you suggest? Should we just take a look quickly at the results of MPAS? Should we continue answering questions? We can stay a bit longer, but I don't know if the rest of the people can do it.
Yeah, I mean, if anybody else has any questions, feel free to put them in the chat or jump in. But I guess while we're waiting for people to think and type, if you want to go over the results of the MPAS demo a bit, that would be great.
Okay, I think it's shown in the screen, right?
Yes, yes.
So essentially, what you see there is the Codee output of what we call the Codee screening report. So overall, Codee has found 9,000 issues in MPAS. It has organized all these 9,000 checkers into types, quality checkers, and optimization checkers. Optimization checkers are related to what you mentioned before: vectorization, memory efficiency, loop interchange, vectorization, offloading, all these type of opportunities to optimize specific code snippets, from loops to anything else that is relevant for optimization. And in the first ranking, you have the quality checkers, that is everything else that is not optimizations. Where that is, we typically recommend in these rankings are prepared so that every single checker is assigned a priority. This comes from our understanding of what the community believes. It is really a must-have in the code software development process, or is more nice to have. So depending on that, the checkers are assigned higher or lower priority. For instance, 30 occurrences of recommendation PWR 072. Definitely a bug that needs to be fixed, because it comes from changes in the Fortran specification. That today, if you use, for instance, the initialization of the variables when they are declared in the same statement, for Fortran, this implies an implicit safe attribute. But this is dangerous because it will mean that the variable will not be created on the heap, will be created on the global storage. So different subroutines will have access to the same space, memory space, accumulating values. And it's probably what the developer doesn't intend to do with that piece of code. So this recommendation 72 is definitely something that the developer needs to analyze and decide whether this implicit safe behavior is correct or not. And the documentation in the online open catalog describes the situation, why it is relevant, and how to fix it, either manually or using the auto-fix capability. The others, for instance, recommendation 63 is that Codee has identified legacy Fortran constructs. Again, if you want to have your code MPAS, assuming that will be executed in many systems with many compilers and modern compilers, getting rid of legacy Fortran construct is a good thing, because in the end, it will provide better compatibility with compilers and will allow compilers typically to generate better and more efficient code. So legacy constructs is something that you should get rid of. And then we have recommendations 8, 7, and 69 that are related to many subroutines where intent is not declared in the procedures, or variables that are declared implicitly, or modules that are used in a subroutine but you don't declare explicitly which variables or the module are actually used or not. So Codee has found hundreds of occurrences of this and provides plenty of auto-fixes for many of the subroutines to fix these issues. So we could continue going top-down through the ranking, trying to analyze and understand what is the status of the code in this moment. If the developers decide to fix recommendation 72, then they would need to use a PW Codee checks report with verbose mode to get all the information about the variables, the statements, the subroutines, the loops that are actually affected by each of the checkers. Exactly the same way of using Codee that you have seen in the initial demo of this webinar. So, and at the very end, if you can scroll down just to finish this thing, you will always get at the very end a summary line that tells you that Codee has analyzed 340 files that contains almost 170,000 lines of code, almost 8,000 loops, more than 2,000 functions that has been analyzed in 16 minutes, finding more than 9,000 checkers. So here you can get a summary of the coverage of Codee for the code base that has been analyzed in terms of something that you can recognize, where you can recognize the speed and the deep analysis that Codee has done over the subroutines, the functions, the loops, and the lines of code of your files. And if some loop is not of function or file was not analyzed, it will be pointed out here. So you can report it to us and we can work on helping you to understand how to fix these non-analyzed files that sometimes happen when you analyze a new Fortran code for the first time. So very, very quickly going through this MPAS results. So definitely the code needs to fix some bugs, and the team needs to consider whether modernizing legacy constructs and enforcing the proper usage of intent, implicit, use-only keywords is worth investing the time. With the tool of Codee, they can speed up the development process. Many days of weeks of work can be saved.
We have 3 minutes left. I want to make sure that you guys have finished discussing the screening report before, letting people know where to contact us, that they can contact me if they need anything else. Is there anything else you would like to add? Oh, I see Eric has a question too on Codee plants.
Yeah,
Okay.
I think maybe you can give Eric an answer to his question, and then give follow up information. And then if any other questions come in, we could spend a little extra time since you have it. But just to wrap up for people who need to leave.
Yeah, absolutely. So Eric, you are saying we do our work open source, so publicly available on GitHub and open to the world to use and contribute to. As such, we try to shy away from using tools that require users to purchase. We especially want tools available on university platforms. Is it common for universities to purchase Codee for their users? Is it a reasonable cost for individuals to purchase a copy to use? To answer your first question, yes, we do have some clients that are universities, and the pricing, it'll depend on how many users are expected to be using Codee. So I guess in that sense, we would have to evaluate how many research groups are interested, and then how many developers would be using. Would Codee be used locally on a laptop, or would it be installed in a supercomputer? There's a lot of different factors, and I would need more specific information to give you a more accurate pricing model.
Indeed, let me point out, for open source projects, for instance, we have a very successful story with, for instance, Climate and Weather Center in Germany. I think it's very relevant because in the end, they are a climate and weather center with their own budgets and resources, but they serve an open community using the ICON open source project. So the interesting thing of this use case is that they have adopted Codee, paying the licenses fees to integrate Codee into CI pipelines that they use internally in the institute, but also any external contributor also contributing code passes through the same CI/CD jobs to verify that the code is actually verifying their coding standards. So in the end, if there are institutions that are strategic for climate and weather, for nuclear, for whatever, ocean modeling, or I don't know, and these institutions have budgets, our licensing model allows to deploy Codee in the software development process hosted by those organizations, so that all the community developing those codes can benefit from it. And starting from there, on that type of deployment, then we typically go case by case, understanding how the development process actually works, to see what makes sense in terms of extending the license to external contributors or not. It's an open conversation typically with the hosting institution that I would say hosts also Codee as host more software tools, or pays for the hardware, pays for the GitHub licenses, pays for other tooling or platforms related to software development process. I hope this makes sense, Eric.
Yeah.
Perfect. I know we're already at the end of the session, so I went ahead and put my email in the chat. I will be your main point of contact if there's anything you need. If you'd like to know more about Codee, potentially schedule a proof of value, please do not hesitate to contact me if you're interested in this, because I see some people that are leaving. And then Julia has another question. Would that extended license normally be project specific or institution wide? Once again, it depends on how many people would have access to the tool in specific. So in the project, how many people are there, or in the institution, how many people would have access to a tool? It pretty much depends on that.
Let me quickly share very, very quickly another maybe resource that, Brian, you can add. Here we have also information about Codee Plus. You can see there is a free tier. You can benefit from Codee formatted for free. So follow the instructions, download it, use it, and that's it. And then we have the plans with increase for where the main driver is the number of developers adopting it. And the major difference between professional and team is that professional is intended for usage by one developer, while team is intended for usage by a organized software development process, typically powered by a continuous integration system. And if you scroll down, you can see that the license is not limited neither to code, projects, runs, reports. And you scroll down, you can also see more information about features that are included or are the difference between each of the plans. Let me say, for instance, if MPAS is the code we have used today for demonstration, I don't know, but let's assume that there is 8 developers in UCAR or NCAR actually maintaining MPAS. And there is a wider community of 80 developers. The typical path to start using Codee is adopt MPAS in MCAR, for instance, for 3 developers with a CI user license, try to adopt Codee integrated in the CI pipeline, so it can start, increase the quality and benefit the whole software development process and all the Fortran developers working around MPAS, starting with a small set of developers to do the testing, the initial deployment, work with us to help you clarify any questions or help you with the adoption. And starting from there, if you are happy, we are happy, we are very flexible in trying to find the appropriate, I would say, licensing plan or plan that can serve the needs of each specific project or institution. Okay, I hope this helps. Many details in the website as well here, and more coming.
Alrighty. I see that there's no more questions in the chat.
Yeah, I think we've exhausted all the questions right now, and I think talking about licensing was probably a good way to finish up. People can think about how that might apply. I did put that link, Manuel, in our resources, so people can examine that and see what might make sense. But yeah, I guess we can take more questions if they pop up if you all have time. But I did just want to say thanks to the people who attended, and thanks to you all from Codee for giving us an overview of the tools and answering some of those questions today. So yeah, appreciate your time.
Thank you. Thank you, Brian, for arranging this, and appreciate everybody who joined the call. Thank you for your time as well.
Thank you very much, Brian. Thank you to all of you for attending. Let's keep it
Thank you
close
all.
touch.